All right, we are starting the lesson, Properties of Exponential Functions. All right, it says we're going to compare and contrast the graphs of y equals 2 to the x and y equals 1/2 to the x.
Can we do this?
So, not exactly. So we're going to add on to what we learned yesterday. So we are going to use the graphing calculators a little bit to help us with the graphs, okay? So let's take a look at these. So on our first line in the calculator in the y equals menu, I'm going to do 2 to the x. And then for the second one, I'm going to do 1/2 to the x. If you want to look at these one at a time, you can come over here and you can turn off the little equals. That's sort of optional. I'm just, since mine are color-coded blue and red, I'm just going to go ahead and let it go.
This is what we did last.
It's literally the same thing.
It is. Yeah.
Okay, but we're going to write stuff we didn't write, so just stay with me. Okay, so there's our graph. Okay? So we have graphed these before. All right. So let's take a look at this. So they both go through 0, 1. One of them goes up from here and goes to 2 and 4 and 8. Yes, we're revisiting some graphs we've seen before, but just hang on. I'm going to add things to it we haven't talked about. Okay, so there's that. And then the other one is just the mirror image. Yes, we talked about this a little bit. Just stay with me. All right. So here's the other one. So we're just going to get them both on there. All right. So this one is y to the y equals. This one is y equals 1/2 to the x. And the one over here is y equals 2 to the x. So it says compare and contrast. There's a couple of things. So what we're going to do is talk about first domain and range. So when you compare and contrast, you want to say how they're the same and how they're different. So how they are the same is that they have the same domain and range. So both have a domain of -infinity to infinity and a range of 0 to infinity, right? Bottom to the top, 0 to infinity. Okay, so that's how they're the same. How are they different?
Mirrored.
Okay, they're mirror images. We're going to go a little bit more into it, though.
One has a negative slope and one has
Okay, it's not exactly slope because it's not constant, but you're getting warmer. So y equals 2 to the x. So 2 to the x grows, and so we're going to say that it is increasing. Y equals 1/2 to the x is decreasing, and we could go even further than that. The 2 to the x, we would say, is exponential growth, and then this one is exponential decay. So what we're really focusing on today is how we can compare, contrast, talk about these, communicate.
We should learn how to make
Okay.
nuclear bombs. Yeah, I'm down.
Okay, so let's go down to the next line. So it says if a is between 0 and 1. So in other words, it's like a fraction or decimal, proper fraction. Okay, so that'd be like the one that has the 1/2. Then no matter what that number is, 1/2, 1/5, so it could be like 1/2, 3/4, 0.8, whatever it is. If it's between 0 and 1, then we're going to say that the function decreases and that it is exponential decay. So we're just kind of getting that straight in our heads. We looked at an example, we've looked at other examples, now we know. If a is greater than 1, and we're assuming that a is positive, that they didn't slap a negative in front of it, then the function increases, and we would call it exponential growth.
Like bunnies breeding.
Technically, yes, it would be like bunnies populating. All right, growing. All right, so that's what we're going to write down for that. On your assignment for today, it's going to ask you questions where you have to explain, this is the kind of stuff that I'm looking for, getting you prepared for that. All right, so now we're going to look at y equals 2 to the x power and 3 to the x power. So let's put, we already have 2 to the x on our calculators. So I'm just going to leave that, but I'm going to come down here and do 3 to the x. Okay? So I have both of them on the screen. So the blue one is the 2 to the x, red is 3 to the x, and I'm going to graph them.
The same steepness.
Okay, so we're looking at it. The red one's going to show up eventually.
So I'm
Oh, look.
Huh.
So, Silvus made a prediction. So which one is steeper?
3 maybe.
3 maybe. Okay, so it's a little bit like slope. This one's going to go up a little faster.
Oh, so
These
now
numbers
it's-
over here are not actually the same, even though that's what they look like. If you looked at the table, you'd see that 3 to the x is a little different. So if we're graphing it over here, 2 to the x is they're both going to go through 0, 1, and then 2 to the x is going to go 2, 4, 8, and then going back this way, it's going to go 1/2, 1/4. So it looks like this. So that one we'll say is y equals 2 to the x. And then 3 to the x also goes through 1, but it's going to go 3, 9. Trying to count this correctly.
Yeah.
So it's going to go up to 9. I guess one more than the other one did. No, I'm in the wrong line. 9's
Yeah.
over here.
I was trying
There
to
we
figure out
go.
what
I went over too far. So it's going to go like this over here, and then it's going to go 1/3, which is actually below the 1/2, and then 1/9. So on this side, it actually goes beneath. I should have color coded that. So they actually flip flop when you get to the other side of the asymptote. So if we're talking about how they're the same, to compare them, they both have the y-intercept 0, okay? And then there's 2 pieces to this. So I wish I had color. Let me color code this, I guess. Let me make the 3 to the x one red, okay? And then the red one actually dips below the other one on this side. So it's actually less steep on this side and more steep on this side. The 3 to the x is. So they're the same that they both have, the y-intercept is 0. They're also both the same that they're both exponential growth and they're both increasing. Okay? Sorry, my handwriting's kind of bad. So that's what's the same about them. So then if we're looking at what's different, okay, if we're talking about differences, we can talk about the left side of the graph versus the right side of the graph. So on the left side, that'd be from -infinity to 0, y equals 2 to the x has higher values. It's the one on top. The one that is 2 to the x is actually on top here. And then if I go from 0 to infinity, y equals 3 to the x has higher values. It's a little steeper if you want to say it that way over here. But they do flip-flop on the left side. So that's the point I really wanted to get across to you guys. I was trying to color code this one so it looks red. This one in red, the 3 to the x, actually has lower values when you get to the left of 0. Okay? So this is just getting us lots of information. And what we want to do is just really analyze all of these. Okay.
The intercept is at 1 on those.
The y-intercept is 1. What did I put? 0?
Yeah.
Okay, thank you. Y-intercept is 1. 0, 1 is what I was trying to get in there. Sorry. I started with 0 and didn't get the 1. Okay, good. Glad you guys are paying attention. So let's go to the third example. There's a whole bunch of functions. So we're going to have 3 to the x, 3 to the x plus 2, 3 to the x minus 1, and 8 times 3 to the x on the same set of axes. And then we'll talk about the transformations. Now we've actually done function transformations quite a bit. So if y equals 3 to the x, we consider to be the parent. Let's try to do some of this before we graph. So if I have y equals 3 to the x and a plus 2 on the end, what do you predict is going to happen?
Gonna start at 2 and go up plus 3.
Okay, so this one's going to start at 1. So this one's going to start 2.
The plus 2 one.
Okay, the plus 2 one is going to actually start at
It's gonna start
3.
higher, but it'll be the
It'll
same.
start higher, so it's actually moved up 2 units.
Moved up.
Okay? So then if I took that parent graph and put a minus 1 on the end, it would do the opposite. That would move it down 1 unit. So this is just the same stuff we learned with functions before. So based on what you know about functions, if I put an 8 in front of this and I'm multiplying this by 8, what is that going to do to the graph? So it will move it a little bit, but I want you to think about multiplying all the values by 8. So if you multiply all the values by 8, won't they get bigger?
Yeah.
Okay, so your line is going to be steeper.
I know, I've been told.
Okay, so your y values will be higher. And technically, when we were talking about functions, this is a vertical stretch, is what we called that. The y values are higher, it's steeper, it's a vertical stretch. That's all different ways of saying the same thing. So if we go over to our calculators and just get these graphs, okay, so I'm going to put 3 to the x on the first one, and then I'm going to put 3 to the x. I don't know, I got to delete some stuff there. I'm just going to clear that out. Okay, 3 to the x, and then plus 2. And then I'm going to change, I guess I could leave that one black. 3 to the x minus 1. And then I can change the color on this. How do I change it though? Orange, that's what I want. Okay, so I'm going to make that one orange, and I'm going to do 3 to the x. It's supposed to be red and orange.
Orange?
And then, because I'm using colors that I actually have that I can draw in. So I'm going to insert the 8 because I forgot it. Okay, there we go. So we got all of our functions in. I'm going to graph them all on the same screen. It's going to be a little messy. And if you're using a calculator that doesn't have the colors, you'll have to keep track of which one is which. So the first one did move up 2 units. You can see that. The next one should go down 1 unit, so it's going to go through 0 instead of 1. And then the 8 one starts over here, and it's going to go high a whole lot sooner. All those values are steeper. Okay? Now I'm going to talk you through how we're going to put this onto the graph. We're just going to copy all this over. I'm going to use the same color, so I'm going to start with red. So I'm going to do 3 to the x in red. So 3 to the x goes through at 0, and then it just has 3, and then 3 squared would be 9. So 3
to the x should go
6.
to 1.
Huh? I'm doing the original 3 to the x. It goes through at 1. I'm doing the parent graph.
I'm pretty sure that goes through 1.
It goes through 1. 3 to the 0 power is 1. And then at 1 it'll be 3, because 3 to the first power is 3. Okay. I don't understand what you're saying, so I'm just going to keep going.
0.
Okay. So there's red, so that is y equals 3 to the x that I have in red. So then the next one I'm going to do in blue.
This is so fun.
I'm going to do 3 to the x plus 2. So all it's going to do is going to take all these points and move them up 2 units. So I'm just going to take where they were, move them up 2. And so it'll look like this. Okay. So that's y equals 3 to the x plus 2.
Sorry, is Colton in this class?
No. Okay, and then the next one I'm going to do in black, I'm just going to use my pencil. 3 to the x minus 1. So it's going to go through 0. So it's, all these points are going to be 1 lower than on the original graph. Okay. Just going to get this done. All right, there we go. And then the 8 one is the one that's the most tricky. That's the one I'm going to do in orange. And so instead of going through at 1, it's going to go through at 8. 1, 2, 3, 4, 5, 6, 7, 8, like this. Okay, and it's going to go back down like that, and then it goes up like this.
How many does it move over?
So this one, instead of being down here at 1, it goes through at 8. And then I'm just getting kind of the general shape in there so you can look at it. So this is just to show you that basically all the things we learned about other functions work for this too. It's not really totally new. It's just combining ideas that we already have. Okay? And you guys were able to predict what it was going to do before we even graphed it. So Good job.